Search in Prolog. Prolog can return more than one answer to a question. It has a built-in search method for going through all the possible rules and facts to obtain all possible answers. Search method depth first search with backtracking. Search in Prolog continued. Prolog programs consist of a database of many Horn clauses. Let's look at a given query. Question mark dash query predicate x full stop. Prolog searches the database from top to bottom and to match the head and parity of the query predicate to a Horn clause already in the database. Search in Prolog continued. Once it has found a match for the head, it checks to see whether it can also match the variables in the body. Does this using unification. Variables can be instantiated to constants. Variables can be matched. If it gets a match, we say it has proved the query. Prolog has a closed word assumption. If it cannot prove a query, then the query is false. Let's look at an example for search. President X, first name X and George Dubia, and second name X and Bush full stop. Prime Minister X, first name X and Maggie, and second name X and Thatcher full stop. Prime Minister X, first name X and Tony, and second name X and Blair full stop. First name Tony Blair and Tony full stop. First name George Bush and George Dubia full stop. Second name Tony Blair and Blair full stop. Second name George Bush and Bush full stop. Is Prime Minister P full stop? The answer is P is equal to Tony Blair. Is not President Tony Blair? The answer is yes. Artificial Intelligence and Prolog. There are three basic steps to using Artificial Intelligence and Prolog. Create the Prolog programs, create a query, and run the query. Let's look at the central ideas of Prolog briefly. There are four ideas in Prolog. They are success or failure, matching, searching, and backtracking. Now let's look at the success and failure. Any computation can be succeed or fail, and this is used as a test mechanism. And matching is any two data items can be compared for similarity. X equal y, and values can be bound to variables in order to allow a match to succeed. X equal y. In our previous slides, we described about the failure and success and also the matching part. Now let's look at the rest of the two. Searching. The whole activity of the Prolog system is to search through various options to find a combination that succeeds. Main search tools are backtracking and recursion. Backtracking. Backtracking is when the system fails during its search, it returns to previous choices to see if making a different choice would allow success. Creating Prolog graphical user interfaces. We have been using Prolog at the command line. This makes it seem of limited use, more retro compared to the other languages, such as Java, which have significant graphical components. But Prolog does not have to be just textual. Various techniques exist for creating graphical user interfaces for Prolog. They are TCL or TK, Jasper, named Java Interface, Visual Basic, and Visual Prolog. There are few real reasons for not considering Prolog for use in commercial settings. Most of the aesthetic and practical issues can be resolved by using Visual Prolog or creating graphical user interfaces. However, building graphical user interfaces complicates what would otherwise be a very simple, economical Prolog program. So, stick to text unless you have a real reason why your program needs a graphical user interface. Prolog can be used to solve most symbolic computation problems using concise and efficient programs. Sometimes it may not be the first language you think of, but don't dismiss outright. Due to its flexibility, you can make it do virtually anything you want. You just have to know how. Artificial intelligence through Prolog. The two languages, Lisp and mainly Prolog, that we talk about this long are the two most common from the several programming languages that are known as artificial intelligence languages, which are used almost exclusively for artificial intelligence applications. What is artificial intelligence? There are various definitions. Let's look at two of them. Building intelligent entities. Getting computers to do tasks which require human intelligence. But what is intelligence? Simple things turn out to be the hardest to automate. Recognizing a face, navigating a busy street, understanding what someone says. All tasks require reasoning or knowledge. Let's learn about the artificial intelligence further. Artificial intelligence or AI. Computers with the ability to mimic or duplicate the functions of the human brain. Let's see what the artificial intelligence systems mean. The people, procedures, hardware, software, data, and knowledge needed to develop computer systems and machines that demonstrate the characteristics of intelligence.